All right, so today we're going to talk about evaporation and energy density. So as you can see, I have created a definition for a pot of soup, and what we're going to do um, first is determine what I call the evaporation mass, and that is the mass of water that is evaporated during the cooking process. So let's take a look and see how we determine the evaporation mass. So the first step in determining the evaporation mass is to determine the mass of the container. And this is 3,945 grams. Now, before we start cooking, we're going to measure the total mass, which is the mass of the container plus the mass of everything in it. And our total mass is 6,850 grams. Next, we throw it on the stove and we let it boil. And lastly, we will measure the reduced total mass, which is the total mass after cooking. And the reduced total mass is 5,730 grams. Okay, so now that we have our measurements, we can determine the evaporation mass. So our measurements were the container mass, the total mass, and the reduced total mass. And the contents mass is, as you can see, the container mass subtracted from the total mass. And the reduced contents mass is going to be the reduced total mass minus the container. And then what we do is subtract the reduced contents mass from the contents mass. And the missing mass is the evaporation mass. And this is the amount of water that left the soup during cooking. So what we're going to do to make this more accurate as far as being a reflection of what we're eating, we're going to reduce the broth by this amount, 1120. So we'll come here. Okay, so what we actually have in our pot of soup is 772 grams. So as you can see, when we did that, the EF jumped way up to 0.9, which is almost at threshold. And the reason it did that is because we lost water, and that causes the EF to go up, which is not good. So what we're going to do is change this here. All right. So this is an accurate reflection of what's in the pot after we cook. And what we're going to need to do is either add water back into the soup, which is probably not a good idea because it will mess up the flavor of the soup. So what we can do is drink a glass of water alongside of our soup. So we got this here, and I've copied and pasted here, and then I have tuned it to 1 cup. So we have 1 cup of beef and barley soup, and then we add water, 1 cup of water. And as you can see, the EF goes down from 0.9 to 0.4. And that's exactly what we want. So you're not going to be able to do this every time you make soup. But the thing to take away from this is that whenever we reduce something, it's a good idea to drink a glass or two of water with it to make sure that you are reducing the energy factor. And we are going to revert this back to what it was, so that if we decide to make this again, it will be the same. So this has been a tutorial on energy density and water and evaporation, and I will see you again soon.